kept going and going until it ground it right out. These are off of a SS Cobalt. This is a solid disc like I talked about earlier. These are vented. So the solid disc is nice and thick. There is a chance you can resurface it. This one here went bad, not only because it started to delaminate, which you can see all the bubbles and the pieces in it, but the runout was way off, which technically runout is a fancy term for the what everybody considers rotor warpage. Rotor warpage actually does happen, but you also can get heat spots, delamination, which is where the surface of the rotor starts to come apart, and that's starting to happen on Hap's car. So we'll get some great Napa parts here soon to replace that. These are the clips. These actually came out of the Blazer, and one of the gentlemen was just asking about whether or not you should change hardware. Different brake systems have different types of hardware. Some of the older GM calipers have that little pin that kind of looks like a V, and you got to slide it in the bottom of the caliper and slide it into the top. That does wear, and when it wears, it'll actually get thinner and allow that caliper to chuck. So when you go forward, step on the brake, you're okay. When you back up and it goes clunk, that's the actual caliper chucking back and forth. A lot of that's due to brake pins and brake clips that are worn and haven't been replaced, and that's what's going to create that movement in the caliper brake system. So depending on the braking system itself, you'll want to replace the hardware with it, because the pins do wear, the bolts, the clips, they all wear, and that's going to create excess slop in the braking system that you just don't want. These rotors, again, they just fell apart, and run out is something we're going to talk about a little bit over there. Rotor thickness, and this is the spec book, which I just got from Bruce. We look everything up online, so every car has a spec book, tells you exactly what runout should be, what standard thickness is of a new rotor, what minimum thickness is, whether or not you can cut the rotor, how much you can cut the rotor. It gives you all that information. Believe it or not, there's a lot about rotors that most people don't understand or don't know, and that causes that 8 out of 10 times we're going to put rotors on the car. This is a micrometer set. If you're not familiar with a micrometer, it's a measuring device that technically measures the thickness of rotors in very itsy increments, thousandths and hundred thousandths increments. So when we're going to measure a rotor, we're going to dial that in, and we're going to look at the reading, and we're going to compare it to the spec. We're going to determine what spec that this rotor should be, whether or not it's within spec or it's below spec. If it's already below spec and it can be cut, there's no cutting it. If it isn't below spec but it's been damaged, then you have to make a mathematical calculation between what is minimum spec, how much can you cut off of it, versus what do you have now, because if that mathematical calculation